Hello, once again, and welcome to, I'll just get rid of that little screen. Welcome to MEL Science. Absolutely lovely to have you here with me this afternoon. And in fact, in the UK, it's a lovely, bright, sunny afternoon. So wherever you are in the world, do please, when you come in, let me know who you are and let me know where you are, so at least I can make it a little bit more of a personal learning journey for you, and make it more like a classroom for me, rather than this kind of strange world we still live in, where there's no students anywhere, and I'm here talking to myself. So in order for me to not talk to myself, if I move that screen here, oh, I've got some, yes, fantastic. Yes, hi, I've got a Mindy, hello, hi, and I've got a Holden, hello, hello. So we just give a couple of minutes for everybody sort of launch in. Graham, and from Uta, hello, and Sandy, lovely to have you, thank you very much for joining. Kimberly, hello Kimberly, from Colorado, that's a lovely name, Muskego, Wisconsin. Charlotte, hello Charlotte, Kimberly and Charlotte. Muskego. So whereabouts is that in Wisconsin? Wisconsin, this side of the States, I think. And Daniel, absolutely classic name. I highly recommend the name. And Ocean, Abigail, and Sushir. I hope I've got the pronunciation right. Sushir. Celeste, and I'm Robert. Hello, Robert. Hello, Graham. Hello, Dan. Jake. Excellent. How are you doing, Jake? I hope you've enjoyed the sunshine today, Jake, my man. Excellent. Hello, Ella. I'm from Scotland. Oh, we're from Scotland. And you live for us. Now, I've seen you before, Ella. Well, I haven't seen you before, but I know that you've been on the webinar before. And Artemis, what a lovely name as well. Artemis. And hello, Franco. And Rachel as well from Maryland. Lovely stuff. Milk, Mika. Hello, Mika. And Chance. Hello. And Sarah, Darren. There's a whole lot of names I don't recognise and I haven't seen before. Hopefully, my name's Sania and Nia. And thank you, Sashir. Excellent. Glad to have our pronunciation is okay. And my first Franco, it's your first. Well, I hope you're going to be okay. So don't forget, everybody. Ebony, hello, Ebony. Ellen and Darren and Shea, lovely. There's loads of you today. Absolutely fantastic to have you on board. So my name's Dan. This is MEL Science, and more specifically MEL Chemistry today. And Chance and Jake, hello. So without much further ado, just for those of you who are new that may not have seen before, I can't see you. I cannot hear you, but I can read what you type. So I can read what I type. Now, if all the way through this sort of webinar, I will ask some questions, and I will answer some questions, and just check how everybody's going, and just check that I'm going the right speed. So if I could, whenever I say, is everybody okay? If you could just give me a little sort of shout, or just say, yes, we're okay, yes, or no, or wait, or something like that. That would be wonderful. So, without much further ado, ladies and gentlemen, we are doing today the artificial sea. So this is the box we're doing today, artificial sea, okay? And we're going to do all experiments as usual. We're going to do all experiments in this very pretty chemistry there. There's no bang and whoa and smash and whoo in this one. It's just beautiful chemistry, okay? So lots of beautiful chemistry in this one and lots to explain. Okay, good, cool. So without much further ado, let's have an equipment check and then we'll put the whole thing into context for you. Hi, Hetty. Hello, Hetty. Are you doing calcium silicate today? Yes, Jake, I'm doing the calcium silicate today. Yes. Okay, so let's just change camera a little bit. Okay, so what you should have on your desk today, and I'll go through Hetty. Hello, Hetty. So I'm going to go through everything today. We're going to go through the chemical seaweed. So first little card. Now you can have the cards in front of you, but I'm going to go through the experiments, show you how they're doing, how they're done, and explain the chemistry. Okay, you're very welcome, Jake. You're very welcome. So we're going to do artificial sea, we're going to do calcium silicate, and we're doing chemical jellyfish. Now we're not going to do them in that order. We're actually going to do them in this order. So we're going to go to seaweed first, because the seaweed takes a little bit of time to cook, okay? When you're making things in chemistry, sometimes the cooking process takes a little bit of time. So you've got to be patient with this one. It'll take about 20 minutes to cook. So we'll start this one and then watch it cook as we go through. Then we're going to do chemical jellyfish and then the calcium silicate. Okay, so I'll just take those out for the moment and then come on to the chemicals. There's a lot of chemicals in this one. Wait for the set. Yes, Ella. Oh, it's absolutely fantastic. I'm so sorry you don't have this set, Ella. Sometimes the post is a bit sort of slow, so I'm really sorry about that. And sorry, Naya. Of course, this video will be put up on the website, and you can then watch it a little bit later on. Hello, Sebastian. Hi, I'm Million in London. Hello, Artemis. Okay, cool. So first of all, we need the potassium hexacyanoferrate, very exotic sounding chemical. So potassium hexacyanoferrate. So you need to make sure you've got that one. Now listen very carefully. You've got copper sulfate. Hi Naya, very well. Thank you, Naya. Oh, you have everything. Excellent quality. Right, so the copper sulfate. Now please remember, this is solid copper sulfate. You look at the bottom, you see little crystals of it. So this is solid copper sulfate, okay? We also have liquid copper sulfate, and we'll come on to that in a second. Right, then you need the zinc sulfate. So this is zinc sulfate, and again, you can see that's a solid crystals of zinc sulfate. Then you should have the iron chloride. So this is iron chloride. Again, that's a liquid, this one. Then we have the liquid glass. Now you need 2 bottles of liquid glass. So this is liquid glass, so sodium silicate, this material. So that's liquid glass. You need 2 of those ones. So make sure that you've got 2 of the sodium silicate or the liquid glass. Now, as I said, we have the copper sulfate. So this is the liquid copper sulfate. So remember, you've got solid copper sulfate crystals and then liquid copper sulfate. Okay, so that's the liquid copper sulfate. And then the last 2 chemicals, we have a manganese sulfate. So not magnesium, but manganese sulfate. I look like a man scientist. I look good. Excellent, Hetty. I'm delighted you look like a man scientist. And then finally, we have the copper hydroxide. Yes, Chloe, yes, no problem at all. I'm going to slow down, so give everybody time to get all these things together. I'm going to set it up first, so I can give you time to set up each individual, so don't panic, don't panic. So here's your copper hydroxide, so copper hydroxide. Okay. Now, the rest of the kit that you need access to some water. So we need some water. And that, if it's just slightly warm, that's fine, but it can be just cold tap water, that's fine. You also need your plastic, so simple plastic beaker that comes in your starter kit. You also need, Eddie, it will be. I just still think Ebony, it will come to you. It will, I promise you. I know there's some issues globally with post and stuff like that, so do be patient. You need your glass beaker from your starter kit. You need 2 little cups. So 2 plastic cups from your starter kit. If you use them up in your starter kit, then any 2 plastic cups will do in this context. You also need your Petri dish. That's for one of the experiments. That's for growing our jellyfish. You need the 2 starter stirring rods. So 2 of those. Then a stirrer. So a little spoon, spoon. And last but not least, you need the syringe. Now, for those of you who've been here before, have I missed 2 pieces? Should the water be slightly warmer than lukewarm? Mine didn't work so well last time. Yeah, if it's just slightly better than lukewarm, that's perfectly fine, Jake. Yeah, nice question. Okay, cool. What have I missed? Ella, what have I missed? What 2 vital pieces of equipment have I missed? Safety specs, of course. So you need our safety specs today also, and our gloves. Now, your gloves come in little packs like this, okay? Can I get some water? Yes, please. No, plenty of time, so don't panic, don't panic. And you need, I've got slightly bigger gloves here. Right, so what's it? Oh, I've done this before. Okay, Hetty, no problem, no problem. So hopefully I can explain some of the science. Direct Master Susha says he has 2 calcium hydroxide. Yes, you might have 2, because there's normally enough chemistry equipment, the chemicals in each of these sets, these wonderful sets, for you to do the experiments twice, okay? So you should have 4 sodium silicates, or the liquid glass, in your set too. Okay, so let me just change the screen a little bit and introduce you. So today we're going to do it with you. Excellent, Sebastian, fantastic. Okay, I haven't started just yet, but I will do in a couple of seconds. I'm going to set some context. So we're going to make some seaweed, some chemical seaweed. Then also we're going to look at these wonderful little jellyfish. So I found some jellyfish that look just like the ones you're going to make. Okay, so I'm going to make some jellyfish. Thank you, Hetty. That's very pleasant. That's very polite. Thank you so much, Hetty. You're welcome. I'm a nice kind of guy. And then finally, did he say? Oh, right, hand sign, excellent. So then we're also going to look at this wonderfully interesting substance called calcium silicate. And it has very interesting, I'm going to do this one at the end, because it really works really rather spookily quickly. It's quite funny. So we'll do that one right at the end, have a look at that curious sort of substance. And then once we've done one of the chemical experiments, I'm going to come back and explain a little bit of the chemistry, see what's going on there. Okay, so without much further ado, let's crack into this show. So we're going to do the chemical seaweed one first. So for this one, okay, so this is chemical seaweed. Okay, we need some water. We need the beaker, okay, and you need the chemicals that you need for this one are the potassium hexacyanoferrate. You need the copper, the solid. This is the crystals. Thank you, Naya. That's very pleasant. Thank you very much. What a wonderful bunch of students we have here, and young scientists, of course, this afternoon. So thank you very much for being here, and thank you for being so polite and nice. That's lovely. So you need the solid copper sulfate. So solid copper sulfate, I'm going to get rid of those. You need, how do I prove text? How do I prove text? Priv. Oh, private. Ebony, if you want to send a little message, you can send it. Your wonderful host today is Razal. And if you just send a text to Raz, and he can then send it to me, okay, if you want to do that separately. So manganese sulfate, so you need the manganese sulfate, you need the zinc sulfate, so I'll just put that up there for you. So that's zinc sulfate, and you also need the iron chloride, so iron chloride, and we don't need that, and we don't need the liquid. And we don't need the liquid glass for this one, and we don't need that one, and we'll put all that one to one side. Okay, so you need a stirrer, so one stirrer, so put the other stirrer to the side. We don't need a syringe, and we do need the spoon. Okay, now let's get my gloves on, and let's get our glasses on and go. Right, any questions so far? Is everybody okay so far? Yes, I've got a yes, I've got one yes. Yep, Sebastian, not really. Hansen, what's from? Hansen, talk to me, what's from? Well, yeah, kinda, yeah, excellent, lovely. I don't have Hansen, oh right, sorry Hansen, but hopefully the set is coming in the post, okay? Oh, your dad hid it. Why did your dad hid your set? Almost, Mindy, almost says. So you need to go and ferret around. Why? Can you repeat what we need? Chloe, of course I can, yeah. It came in February. Oh, I see. Okay, good. Okay, great. So just a quick recap, you need the potassium hexacyanoferrate, you need the solid copper sulfate, you need the manganese sulfate, so manganese Mn, so rather than Mg sulfate, you need the zinc sulfate, so there's the white powder zinc sulfate there, and you need the iron chloride. Okay, cool. Right, so first things first. Now you guys have already had these kits before, so obviously what we need to do is depress the little tiny safety plugs out of the liquids, okay? So we're going to do that first, just to sort of help things along. So with your little pin, so this is your little tiny paper clip, so that's used to depress the little plugs out. I'm going to use a bit of paper just to make sure I don't contaminate the chemicals. So if we look at the iron chloride first, let's just push the little tiny safety plug out of the iron chloride. And I forgot my specs, so on go the specs. Cool. Right, so just depress the little tiny plug out of the iron chloride now. And again, sometimes they can be quite stiff, so you have to be quite determined to depress that little lid out there. I'm just going to pop that on there. Just give that a little wipe with a bit of tissue. Now the next liquid I've got, and there's only two liquids in this one here, is the manganese sulfate. So again, let's just get the little tiny safety plug out of that one. Pop that out like so. This one's proving a little bit more resistive than normal. And of course, as usual, there will be a couple of jokes thrown in just to keep you entertained and amused in between these little bites of chemistry. Okay, so first things first, what you need to do is pour about 100 mils of water into your beaker. So pour 100 mils of water into your beaker. About 100 mils of water into your beaker like that. Okay, so this is the chemical Seaweed one, and again, as I said before, this one takes a little bit of time to grow, so it's like a lot of chemical experiments, sometimes you've got to wait a little bit. Okay, and now what we need to do is dissolve in that water 2 big scoops of the potassium hexacyanoferrate. So the label here is yellow, so you want to dissolve 2 big scoops in that water. Okay, so you can be reasonably generous with those. So 1 big scoop, and then another big scoop. Okay. Put that there on that. Cool. Now it takes about a minute or 2 to dissolve. That's why I said if it's ever so slightly warm, the water, they make it a little bit better, but it's fine. It's fairly soluble, this salt, so don't panic too much. So then dissolve that away. So obviously what we've created here is a solution of potassium hexacyanoferrate. Now did you see, does everybody see this is a solid crystals? You can see the solid crystals going into the water, okay? And they are actually dissolving. Why isn't he wearing gloves? I am, Soshir, I'm wearing gloves, look, I promise, look. Soshir, I'm wearing gloves. And I can't wear the gloves that come in the boxes are too small for my hands, okay? But very important point, why does the solid disappear? Why does the solid disappear in the water here? Where does it go? What's it doing? They are transparent. They are, yeah. It's quite cloudy, Jake. Yes, it will be to start with, but it should clear up a little bit. It's dissolving. It's dissolving. That means that the atoms and the molecule are going into the water as ions, okay? So they're charged, they're becoming charged ions, which means that all of the atoms, can you see in this wonderful thing, it's got potassium, look, potassium hexacyanoferrate. So we've got 1 big compound ion, and then you've got potassium ions here. So that comes apart in the water, so that molecule separates into ions. So potassium ions swimming around, and then the hexacyanoferrate ions swimming around. Okay, so just don't panic if that's not quite Are they positive ions? Yes, they are both positive and negative, okay, in here. So you've got positive and negative ions in here. The potassium ions, of course, will be positive, and the hexacyanoferrate ions are going to be negative, okay. Now, if you are negative, are you going to be attracted to negative or positive people? If you're negative, are you going to be attracted to negative or positive people? What? What do you think? Yay! So negatives attract positives, and positives attract negatives. How much of each? Two big scoops in that one. MnSO4 isn't on the card of this experiment. It isn't. Marcus, you are paying attention. Fantastic. It is not on this list. So I thought what I would do deliberately here is stick in a little tiny distraction to see who's actually paying attention here. But excellent. I have a hot plate with magnetic stirrer and butcher funnel. Buchner funnel as well, a 5 flask. My gosh, Kathy, amazing. There's a proper chemist there, Kathy, by the sound of things. Okay, so don't have the manganese sulfate for this one. Okay, so we just need, of course, the copper sulfate, the zinc sulfate, and the iron chloride for this one. Okay, so now that mine has dissolved. Okay, so you can see it's now dissolved. No, me? Ah, not at all, Jake. Okay, so first things first, we need the solid copper sulfate. So not the liquid, the copper. This is the fact here. So we want the solid copper sulfate, not the liquid one. The copper. I'm drinking hot cocoa in my glass of water. Oh, Mindy, for glasses, hey. So what you want to do is allow a match head's worth of the crystals of copper sulfate, okay? Match head's worth of the crystals gently into one bit of the beaker, okay? So we just gently tap that and pop those in like so. Now you'll see almost immediately as soon as you do that there's a slight browning crystallization sort of taking place immediately. So put a couple of those in there like that. And then on the opposite side, you put the zinc sulfate. So a bit of zinc sulfate on the other side. So the same thing, about 2 or 3 match heads worth of the zinc sulfate on the other side. Okay, like so. Now, very, very, very important, ladies and gentlemen, what you don't move this beaker around, so leave it in place, okay, because what's happening is the chemical reaction is going to take about 20 minutes to form, and as it forms, we are then going to put in a little bit of iron chloride. So you're not going to put the iron chloride in now, you're going to put it in about sort of 20 minutes time. So don't move that that glass, just leave it there because these very delicate little strands of seaweed are going to form, okay? So I'm just going to, I don't think you're going to move, I'm going to move very gently out of the way, and I'll bring it back when we do the other one. So this is the chemical seaweed. So as again, it does take a little bit of time to form, so don't panic. Okay? Right, so let's move that out of the way. And let's get on with a few jellyfish. Shall we make a couple of jellyfish first, and then I'll get on and explain some of the chemistry for the moment. Okay, is that okay? Shall we do it? Can we do the next one? Should we do the next one and then I'll explain some of the chemistry behind it? Is that okay with everybody? Everybody's busy doing something. Yep. Nia says yes. Kathy says yes. Rachel says yes. Sebastian, Shazia. Excellent. Awesome. Super. Right. So what we'll do then, we'll do the chemical jellyfish. And again, I'll swap cameras for you so we can see this one. I thought of a joke. Ella, jokes are coming. Okay, joke. This is so fun. Hetty, you're very welcome. You're very welcome. So but Hetty, watch the side of the little beaker as well. And also as well, what I forgot to mention, Lucas, you're very welcome. Jokes coming, Sushir, jokes coming. What I forgot to mention, of course, is the certificates. If you would like, because you've taken part in a little chemistry experiment here, Ella, what do you want for dessert? What do I want for dessert? Jellyfish, yes! Ella, that joke's almost as good as mine, okay? Almost as good. But if you'd like a little certificate to come, personalised certificate from me, because you joined this little chemistry webinar, please just type into the chat, send a little note to Rizal, or go online and just register your details and stuff like that, and I will send you a little certificate to reflect and remind you that you attended this chemical jellyfish webinar. Okay, cool. So please do get the little certificates out at request if you would like one. Okay, cool. Right. So what we're going to do now, the jellyfish. So for that one, we need the Petri dish. So grab your Petri dish. We now need the liquid glass, and of course we're going to have to empty the liquid glass. certificate. Yes, Lucas, if you just type into the chat or connect the link, and Rizal, the monitor today, will send you a little link and you can fill that in. So please do, if you'd like, that would be brilliant. So a little personal note from me. Okay, cool. So for the jellyfish one, what we need is the liquid glass, a little bit of liquid glass. You need here the iron chloride, so iron chloride. This time you definitely need the manganese sulfate. So in the chat there, you've got a link there to grab your certificate if you'd like one. Just click on the link, it's just in the chat there, hopefully you've got that. And Josie, you've got a little tiny link there as well. Okay, this is the manganese sulfate, so you definitely need the manganese sulfate this time round. Okay. And then the copper sulfate liquid. So here is the copper sulfate liquid, so you definitely need this one now. So those are your 4 chemicals for this one, okay? Sorry, sit now. Yep, sure, you're very welcome. It's an absolute problem. Oh, it's in the link. It is in the link. Yes, it's in the link. Right, so first things first, let's get the chemicals safety plunger removed from the top, or depressed into the top of the bottle, the neck of the bottle. Da, 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 da. And you don't need a book and a flask for this one. So push that into there like so. Again, give the paperclip a little bit of a poke. Now, I think I did this one already. I did, so I was going to put that there like so. And then the manganese sulfate. I think I did that one earlier as well. Just keeping you on your toes, as it were, there. And then finally, let's give that a little wipe too. Your copper sulfate. So we pop the little plug out of the copper sulfate. Cool, like so. Cool. Right, so just leave that for a second and just check that everybody is okay. Is everybody okay? Jake, what is the plug made of, Dan? That is an excellent question, Jake. The precise chemical formula for that plug, I don't know. But as you can probably guess, Jake, and I'm pretty sure you probably guessed this, that it has to be particularly inert, so it doesn't react with any of the chemicals, okay, that are in there. But that's interesting. That's one of the times I've not been able to answer that question, so I will go find that out. But it's bound to be, obviously, a fairly spongy, resistant polymer, like a kind of PVC-based bung, I would have thought, something of that nature. Okay, cool. Right, if everybody's ready, it's not jellyfish time. Yes, jellyfish time! So we're going to get the liquid soap. So what you want to do with the liquid glass, this is the sodium silicate, is put the whole of this bottle, so squeeze the whole of the bottle into your Petri dish. So put the liquid glass into your Petri dish, okay? Now what you'll find is that it doesn't quite cover the bottom of it, so you're going to have to give the... sorry, Chloe, don't panic, don't panic. I'm just going to move that around a little bit. So just move the liquid glass around a little bit there, and you'll find that it should cover the whole of the plate, like so. Okay. Okay, so just give it a little tiny sort of swirl so you can actually cover the whole. Can you touch it? Kathy, try not to touch this. It's fine, you can touch it, but you should have your little gloves on. Do we pour the whole thing in? So yes, pour the whole of that bottle in. So the whole bottle goes into the Petri dish, okay? Yeah. Now, no, please don't eat it. Never eat anything. Assume everything within the chemistry set is non-edible, okay? So please don't do that. Add no water. No, you don't add any water to this at all. So just the sodium silicate, or the liquid glass, okay? So just add that. You don't need any water in this at all, only the chemicals that are there. Okay, cool. Right, so what we're going to do is we're going to start with some copper, the liquid copper sulfate, okay? And one bottle, yeah, the whole bottle, Sashia, yeah. Okay, so then what we're going to do is I'm going to drop just one drop, but I'll probably maybe about 4 or 5 drops. If you put the liquid glass on little drops, then rest on it. Spread just on. Sure, yeah, fine, Mindy. No, thank you for that, yeah. Can you check on the beaker? Yes, of course. I'll come back to the beaker in a second, actually, I'll just come back to the beaker in a second, if you don't mind. Right, so put one drop at different heights, so maybe about 5 different heights, okay? So that was about 3 or 4 centimetres, and then a bit more, and then a bit higher, and then a bit lower. So I've got, you see, immediately that copper sulfate hits the liquid glass. It forms what are called precipitates. Yeah. It's these beautiful, tiny little, please repeat what we pour in the dish. Chloe, you pour the liquid glass in the dish, Zoe. Say, Chloe, sorry. It's the liquid glass, the sodium silicate. Okay, liquid glass in the dish. And it's the Petri dish, yeah. So the next thing we're going to do to make another little bit of a different coloured jellyfish, of course, we're going to use the manganese sulfate. So again, what you need to do is drop about 5 drops of the manganese sulfate at different heights above your Petri dish, okay? So again, quite low, a bit higher up. There's 2 little drops there. Okay, so some lovely, beautiful little tiny white jellyfish this time round. And then lastly, I'm going to drop some of the iron chloride. So this is the iron chloride into the Petri dish. And again, repeat the same routine from different heights, so we're creating different size jellyfish. And look at that, lovely brown jellyfish. Isn't that beautiful? How wonderful is that? Isn't that lovely? I hope. Now, with this one, be very careful, okay? Be very careful. If you don't move the tray, so don't move the Petri dish, okay, too much, what will happen is there is actually water in the sodium silicate, okay? There's a little bit of water, and that will eventually dry out. That will eventually evaporate. And actually, over about 2 or 3 days, that will become really quite solid, and you can actually keep that for a long time. Isn't that awesome? Thank you, Ella. Yeah. Can I do the seaweed in my 100 ml flask? My dad accidentally threw away my beaker. Yes, you can. Yes, you can. In fact, it's actually better, Kathy, because to see the seaweed properly, it needs to be in a glass container. So if you've got a really clear glass, can you do a close up, please? Yes, I can. Actually, I'm going to bring that up to you and show you. Sorry, who was it? This is beautiful, soothing chemistry. This is wonderful, soothing chemistry. So I can't see who that was. I can't remember. Hang on. Let me to dry. It's a bit dry. Kathy, yeah. Kathy, just do it in a glass, just a normal glass, okay? Like a simple clear wall glass beaker. And you just wash it out eventually afterwards, okay? Can you close up? Yes, I can. It says for 2-3. It'll actually last a lot longer than that. It's a little bit dirty. Kathy, just give it a little clean. Okay, I'm going to bring this up so that you can see it, hopefully. My little jellyfish is starting to swim around a little bit. Can you see that? So jellyfish swimming around a little bit there, and hopefully you can see those beautiful little drops of jellyfish, just like the ones that I sort of showed you earlier. And as I said, if you don't move your Petri dish too much and allow that water to evaporate out, you'll see that it becomes quite solid, quite tacky. Isn't that cool, Naya? Yes, the seaweed, yeah! The seaweed, unfortunately, will not last. Okay, and if I bring the seaweed up a little bit, it's quite difficult. I'm just going to try if I can show you seaweed slightly close up. Hang on, let's just see if I can see it slightly close up. Now, this may or may not work, so bear with me. Hand cam. If I look at I might not be able to do it. No, I can't do it, but I shall try. I'm going to try and lift it up for you. That one's not playing fair today, so we're going to try and lift it up for you. Move that out of the way. So very carefully. Now, this is what you shouldn't do at home because, of course, it's very fragile, but hopefully if you can see it there. Can everybody see that? My beautiful little tiny white zinc hexacyanoferrate seaweed strands. And if I just turn it around a little bit, you can see the brown copper hexacyanoferrate strands. So just let this grow for a minute. It will grow and it'll keep growing, and it really becomes quite a dense pile of seaweed, chemical seaweed. At this point, can you please go back and use the iron? Can everybody find the iron chloride? Can everybody find the iron chloride and put about 5 to 10 drops of the iron chloride into your seaweed? Okay, so if you put about 5 to 10 drops, the copper looks really beautiful. It is absolutely beautiful, isn't it, Ella? Yes. You see, Ella, why would you not go and pursue a career in chemistry, okay? But this, I think, is even more beautiful, this one here. If you look at the iron chloride, so just put like 4 or 5 drops of the iron chloride into there as well, and see what happens with that. Rather beautiful blue, Prussian blue kind of thing forms. Yes, it is, Artemis, it is indeed. Yeah, they're like little orbs, they are indeed. Yeah, that's a lovely analogy, that. Thank you. Okay, so what's actually happening? Let's look at the chemistry of what's actually happening here. If we just go... So I said as soon as you see, you have the liquid glass, that's sodium silicate. It looks like the algae except blue. That's right, yeah, look. It looks, hang on, if I just go this way again. Does it not, or does it not look a little bit like that? And the jellyfish definitely look like that, okay? So what you've actually formed, here, if you look at the periodic table, all of these different elements exist in nature as atoms, okay? They look the same. Yes, they do, they look identical. And they look at atoms. But when you dissolve some salt, you know, some sodium chloride, oh, your mum was called, sorry, Hetty, sorry. Yeah, it's a lovely name, Artemis, fantastic name. But when you put salt in some water and dissolve it, just like we did with the potassium hexacyanoferrate, the molecules separate into ions, charged ions. Some are positive and some are negative. So they swim around, the negative ions swim around in the solution looking for positive ions. And when they find, they bond, they form another chemical reaction. And the negative ions swimming around looking for positive ions, they bond with those and form a different chemical reaction. And you can see that here because it actually forms what's called a visible precipitate. And all precipitates are generally visible. But here it forms a precipitate, which is an insoluble solid. Okay, so you can actually see here, if I look down here again, you can see here the little dot of the insoluble solid. Okay, is E equals mc squared. Ebony, yes it is. Einstein's wonderful formula for explaining how energy relates to mass and the speed of light. It is. Okay, cool. So if I can explain this a little bit better, if you look at, say for example, just to show how this chemistry kind of works and how the ions and atoms bond, yes, Sushir, ions are positive or negative. Yeah, they can be either positive ions. So here, sodium, can you see elemental sodium here? There's a white silvery metal. And this is one of the wonderful things about chemistry, the magic of chemistry. It's like a magic hat, this, okay? So sodium itself is a white, silvery, soft metal, okay? Atoms of sodium, okay? Now, if you look at chlorine gas here on the other side, on the halogens, on the other side of the periodic table here, chlorine, okay, like you find in your swimming pools, you don't need magic, you just need science indeed. It's a yellow gas. So we have a silver metal with a yellow gas, okay? And if you react them together, you form sodium chloride, which of course is the salt you eat, and it's a white solid. So we've got silver metal, green gas, react them together, and they form a white solid, which is sodium chloride. Now I can show you a little video clip. So if you don't mind, I'm just going to show you.
This reaction can be safely demonstrated in school.
So I'm just going to show you a brief video clip of the reaction between that metal and the chlorine to show you how that reacts, and then come back to explaining those salts. Okay, so give me a couple of seconds. It's only short, little tiny YouTube.
This reaction can be safely demonstrated in school. In this case, chlorine has been placed in a flask, and some sand is used to protect the glass from the heat produced in the reaction. A long syringe needle has been used to pick up a small piece of sodium, and using the glass tube, it is dropped into the sand. The syringe is then used to deliver a few drops of water, which causes the sodium to ignite and then react with the chlorine. The product is sodium chloride, which appears white only when excess chlorine has been...
Isn't that cool? So that's the formation of sodium chloride. So the sodium atoms and the chloride molecules come together and they react to form ions. They've got ions in a compound. Okay, so sodium ions, which are positive, and chlorine. Yes, Ella, yeah. So the sodium metal was reacting with the chlorine gas, goes from sodium atoms to sodium ions, and the chlorine gas goes from chlorine molecules, and they become chloride ions, and they're negative, and they combine, okay? So all of chemistry is about swapping effectively ions. Is it possible? Yes, yes I can. If you'd like to, I'll redo it at the end, if that's okay, Ella. I'll redo that at the end. Okay, cool. Right, let's go on. I actually haven't told a joke. I haven't told any jokes so far. Would anybody like to hear a couple of jokes? Since I'm... Krish, absolutely fantastic. Perfect, Krish. That's lovely chemistry. Jake, yes. Couple of jokes, okay. Okay, what did the beach say? What did the beach say when it saw the tide coming in? What did the beach say when it saw the tide coming in? Long time no see! Long time no see. Okay, Nesbitt. Oh my God, Nesbitt, thank you so much. Hopefully a bit of the chemistry. How about a knock-knock joke? Good knock-knock joke, everybody? Okay. Anybody ready for a knock-knock joke? Cool. Okay. Knock-knock. 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 Hawaii. 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 I'm good. How are you? Get it? I'm good. How are you? How are you? Hey, I didn't say they were going to be good. I just said them with jokes, as always. There we go. Anyway, on with the show. Right. You're going to be falling off your chair before now. Right. Let's get on. Okay, I've got another one for you at the end, Jake. A classic one for you at the Jake. Jake, hey, I got a discerning audience here. Right, let's do experiment number 3. Okay, so experiment number 3, and that is, of course, our wonderful substance here, calcium silicate. So we're going to make this calcium silicate, okay? Okay, Dan, you're officially coming. Thank you very much, Ella. I appreciate that. Here all day. Well, at least for this afternoon. It's a classic. I only wish that it was my joke. I've got another one. They're coming for you, Jake. So we're going to move this one out of the way. I'm going to move my little jellyfish out of the way for the moment. Okay, just put that there to start with. Okay, so for the calcium silicate, so we're going to do this one now. So we're going to do calcium silicate. Just move that there here. So we're going to do calcium silicate. So you need 2 of your little beakers, so little plastic beakers. So 2 plastic beakers. Okay. I know you can't really quite see that. So 2 little plastic beakers. And now again, we're going to have another pot of our liquid glass. So if you get some liquid glass for this one, okay. Hopefully everybody's okay with that one. We also need some water, so a little bit of water. We need our syringe, so liquid glass, water, and syringe. You also need the calcium hydroxide, so calcium hydroxide and sodium silicate, okay? So calcium hydroxide and sodium silicate. Sebastian, it's an absolute classic. The argon jokes are a classic one, okay? We're glad you're on the trail with the chemistry. You also need your little stirrer, okay? So a little stirrer. So first things first. You get the liquid glass. If you just get the liquid glass, okay. Now, of course, we've got to remove the safety plug from the liquid glass. So again, excuse me, Ebony. Sorry, Ebony. I have to go now. Sorry, Hetty, no problem. I hope to see you next time. Don't forget to get your certificate and just pop that into the link. Stay safe, stay well, have a great week ahead, okay? Cold water. Yes, cold water for this one, Jake. Yep. Hetty, it was so interesting. You're very welcome, Hetty. A pleasure. I shall hopefully see you next week, either Saturday or Sunday. What do we do in this lesson? Oh, in this lesson, okay. This one we're going to look at this really unusual substance called calcium silicate. So we need, first of all, and I'll explain the calcium silicate in a second, Ebony. Okay, so put your little safety plug down like so. Okay, and put the whole bottle, Hetty, bye! I hope to see you again soon, Hetty, thank you so much. So put the whole of that bottle of the liquid glass into one. So that's it. All that's in this glass is one container of the sodium silicate, or the liquid glass, otherwise known as liquid glass. Okay. Now in this, so put that to one side. Now in this one here, we're going to put 10 mils of water. So put 10 mils of water. Ebony, I shall explain that all in a second, Ebony. So we put the 10 mils of water, okay, into our beaker here. And of course, as you remember, all the chemistry here, of course, water, the formula for water is H2O. And of course, in here, in water, we have hydrogen ions, H plus ions, and OH minus ions, hydroxide ions. And they're whizzing around, combining, combining, okay, and dissociating and stuff like that. So they're coming apart in here. And in here, of course, we've got sodium silicate, so the sodium ions and silicate ions, okay? How does liquid glass, Artemis? How does liquid glass, you have to manufacture it. It doesn't form, that doesn't occur naturally. You have to actually manufacture sodium silicate, okay? Right, Now we form the calcium hydroxide. So this is calcium hydroxide. This, of course, does occur naturally. H2 and OH. That's right, Ella. It does indeed. Yeah. Okay. Now you're going to use the whole bottle. You're very welcome, Artemis. You use the whole bottle into the water. So just the water here. Okay. So put the whole bottle into water. So it's quite a lot of it. So put the whole bottle. You might have to give the bottle a little tap to make sure the whole lot's in there. Okay, and this isn't terribly soluble, this stuff, okay? So this is calcium hydroxide. Or another word for calcium hydroxide, of course, is slaked lime. Okay, now what you're going to do is give that a really good stir for about 30 seconds, 30, 40 seconds. So give that a really good stir. You'll see that it doesn't want to dissolve terribly well, okay? You can see that it doesn't really want to dissolve massively well, and that's part of our little trick here. Okay. So stir, 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 stir for about 30 seconds. Guys and girls, is everybody okay so far? Everybody okay? It's all gone very quiet. I trust you're all busy stirring. Yes, Sebastian, thank you. Good. So stir, 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 stir. So about 30 seconds. Right, now the next bit, can you wait? Yes, I can. Yes, 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 yes. Sure, no problem, Chloe. No problem. I don't want to dissolve. No, Ella, it's not particularly massively soluble. It is soluble. It is obviously soluble, but it's some things are really super soluble. So, for example, sodium chloride. You know, if you try at home, if you want a little experiment, you can do at home. Lee, if you put liquid glass on your arm, can you go please and wash it off? It's perfectly fine, but if you just go and wash it off with some nice running water, okay, that's perfectly fine, okay, Lee? And if anybody does spill things, of course, things do spill, of course, on tables, is what you do with liquids, of course, is dry wipe it, then wet wipe it with a clean white towel, and then dry wipe it again and throw that away, okay? And if anything, gosh, should get into your eye, please, 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 always rinse it for about a minute, 5 minutes, 10 minutes, something like that. Just running water over your eye. And of course, if there's any issues, you must call an ambulance. Okay, but you should hopefully be okay. Your glasses on, you've got your gloves on, you'll be fine. Nothing here is terribly toxic, so don't panic. Okay, so here we have the calcium hydroxide solution. So again, the calcium ions have gone into solution as Ca2 plus ions, and then they're separated from the hydroxide ions, and they're in solution as OH minus ions. And so they're looking for opposites, okay, to bond with. Now, here's the little trick. Now, this bit here, I recently acquired a vial of HCl and a drop hit my arm. Kathy, well, HCl, whilst it's a very strong acid, okay, hopefully the molarity, the strength of the acid was very low molar. So, for example, like 0.01 or 0.1 molar. So, hopefully not very strong. And like your stomach acid, which is very strong, okay? Which is why, if anybody's been ill and they've had to throw up, of course, it makes your teeth really furry, doesn't it? I don't know has anybody noticed that? Has anybody noticed that when they're ill, unfortunately, it makes your teeth really furry? Has anybody noticed that? 0.1 molar, fine, no problem. Yeah, exactly. Because if you throw up, no, not really, okay, hopefully you never get ill, Ella. It's one of the worst feelings in the world, being sick. But if you do throw up, some of your stomach acid, which is hydrochloric acid, okay, actually starts to attack badly your teeth. The enamel in your teeth is made of a substance called calcium fluorapatite, and the hydrochloric acid attacks that and absolutely horribly damages your teeth. So actually, if you are ever ill, the best thing to do, actually, don't rinse your mouth out, but put some toothpaste in your mouth and allow some of the calcium and the fluoride ions again in the toothpaste to recombine and attach themselves and help repair your enamel. Okay, so ready? So what we've got to do, when you've got the sodium silicate, the liquid glass, okay, calcium fluoride, it's calcium fluorapatite. It's called calcium fluorapatite, Ella. It's really tight time, you know. Jake, I'm almost there. Sorry, Jake, I hasn't put you off for tea, Jake. I hope, hopefully not. So what we're going to do now is you're going to pour very quickly one to the other for a couple of seconds, and then something strange and magical takes place, okay? So ready with me? So you're going to pour one into the other and backwards and forwards, okay? Ready? Okay. And then something really rather magical should take place in a couple of seconds. Ta-da! Look at that. It's gone completely solid. So my gunky, and you can actually put your finger in here and have a little figure around with the gunky stuff, okay? So you can put your gloved finger into that and just look at this really wonderful substance. So here what we've got is calcium. We've just formed calcium silicate. You can put your finger in there. Isn't that weird? Isn't that gunky? This is science, pure science, Ella, indeed. Look at that. So where did that gunk come from, eh? Where did that gunk come from? Well, let me explain. Hopefully that's worked, everybody. Has that worked? It looks like porridge. What is it used for? Calcium, Jake, lovely question. I'll come on to that in a second. Isn't that really cool? That's super cool. I'm just going to take those gloves off for a second. So what's actually happening here, in here is the sodium silicate, the sodium ions come apart and are easily replaced with the calcium ions. It may be used as a bandage. It can be, but actually the main use for calcium silicate is actually as a fire retardant in paints and plasterboard walling materials, stuff like that. So they put this substance in here into a sort of paints and to plasterboards and stuff like that. So actually it really, really significantly inhibits the ability for things to burn. Okay, so really interesting substance, calcium silicate. So what's actually happening is you put the calcium hydroxide, so they became the calcium ions swimming around, okay? And then the sodium ions are swimming around too, but they've left their silicate knocking them, and the silicate's going, hey, what about me? And the calcium comes along and goes, ooh, I like you. And so remember, it didn't dissolve terribly well, the calcium hydroxide. So there's lots of little particles knocking about, and what happens is that when it bonds, when the calcium attaches itself to silicate, it forms a little spike. Millions and millions and millions of little spikes. So a bit like birds, you know, those kind of funny little things, they stick together like that. So suddenly you had millions and millions and millions of like little balls with those little spikes on them of calcium silicate, and they at once locked together. They didn't do it immediately, but eventually after like sort of second or third turn, all those little spikes, there's millions and millions and millions of them, like little Furbies going, broof, and they all stuck together. Ella, and hopefully that experiment's in this kit. That's a lovely question. It's all to do about ions and how chemical reactions take place in solutions, okay? And what we've done is we've looked at two precipitate reactions. Now this isn't a precipitate reaction as such, it's forming a different kind of chemical reaction involving ions, and when you swap the ions, something very different takes place, okay? Different chemical compound. Okay, cool. Is that okay? Is everybody okay with that? Does that make sense? Have you got any questions? Any questions? You guys, I'm so sorry I can't see you and be a bit more interactive, so yay! Excellent, excellent. Hello, you're very welcome. One last little joke, maybe? One last little joke? Nesbit, you're very welcome, Nesbit. I'm absolutely pleased you liked it. Yes, yes, okay. Which shoes have the least friction? Which shoes have the least friction? Anybody? Which shoes have the least friction? Whoops. Slippers! Slippers! Get it? Slippers! Can you still hear me? What is the white stuff supposed to be? Artificial C. That's not the artificial C bit, to be honest. My question, can we touch the calcium with your fingers? Claren, yes you can. As long as you've got your gloves on, you can put your fingers in there and have a little poke about. Yeah, absolutely. Susan, you're very welcome, and I'm glad Jake is also... Got another Jake! Got another Jake on the show! On the webinar, that is. I'm absolutely delighted. What fish is made of two sodium ion atoms? 2Na. Can we look back at the seaweed? Yes, yes, of course. I'm going to show you the seaweed. I'm just going to bring the seaweed back up for you. So if I just bring this very delicately back up, does the calcium stay solid? It will get more and more solid, yeah. Now look at my seaweed. Look at that beautiful seaweed. Hopefully you've enjoyed that, and that's my I'm bringing it up here, but you shouldn't really moon shoes, no slippers. Okay, hopefully you can see that, my beautiful seaweed. You shouldn't move it too, because it's very, 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 very gentle. Okay, so here's my wonderful sort of chemical seaweed. So all you've got to do, and I hope that's worked for you. I hope that's been okay. When you finish with that, of course, and that won't, you can't keep it unfortunately. So just put it away. We can put the calcium on a match and try to light it. It will not catch fire. Kieran, only with your sort of adult supervision, hopefully, but it will simply not catch fire. That won't catch fire at all. It's a very serious kind of fire retardant. Okay, so fire retardant. And I think I went through all of the slides. I think so. I showed you that. I showed you the formation of sodium chloride. I showed you the video. Showed you how ions formed and osmosis. Okay, cool. But what I didn't do quickly is explain why the seaweed actually forms. Do we do the poll? Yes, please do the poll. If you'd like to do the poll, that'd be great. If you've liked the lesson, then lovely. And what was the osmosis? Jake, yeah, the osmosis, right. So what was happening when you put the, say for example, the copper crystals, where's my copper gone? When you put the copper crystals into the potassium hexacyanoferrate solution, what forms is a precipitate forms on the surface of the crystal, but it lets water in like a tea bag. You know, water can go into a tea bag, but the tea leaves don't come out. So the potassium hexacyanoferrate can't, the copper crystals can't get out, but the water can go in, and so it forms a big bubble, and it's like a little sort of spongy case, which then bursts. And as it bursts, more of the potassium hexacyanoferrate can come in and touch the copper crystal, and then form another little layer, as it were, of insoluble precipitate, and it grows up like that. So you form this little thing through osmosis. The water's coming in through osmosis, and the water molecules in, and it forms this little bubble, that bursts, and then more solution comes in, forms another one, bursts, and so on and so forth. Is it just me, or do you keep freezing? I'm not sure. Do I keep freezing? I'll just check. Hang on. I'll just check. Hang on.
I started using Doodly recently.
Hang on. You're well. Hang on. Wow. So something. Just back to the face cam again. Where are we going? You froze once. Great, thanks. You're very welcome, Jake. You're very welcome. So thank you very much for attending. I hope that's been useful. I hope that's been fun. I hope it's been. I hope you managed to explain everything okay. Can you touch the calcium with your bare finger? Try not to. It's not going to harm you, but it's better done with a glove. Okay. So on that note, Naim, you're very welcome. So I'll hope to see you next time. Yes, lovely. Thanks, Jake. Thank you very so much. Thank you, Sushir. Can you unmute me? Kathy, I can't ever hear you. I'm so sorry because the way we do. Would you like to have a certificate? Thanks. Yes, if you'd like the certificate, just click on the link in the chat and you'll get a certificate. Jesse, Marcus, bye! Okay, so I shall just love and leave you, and I hope to see you next week. You wonderful, wonderful students. Thank you so much.